On M5-126, we're working with some yogurt shops cones. So number one says a frozen yogurt shop advertises that their frozen yogurt is now sold in cones that hold 25% more than the old cones. The old cone had a radius of 3.75 and a height of 11. The length of the radius, the new cone is the same as the length of the old one was the height of the new cone. So basically, that's all that's changing. And we are basically kind of needing to work backwards to find the new one. So we're going to start by finding what the volume of the old cones is, because that way we know the volume of the new cones. So the old cone had a radius of 3.75 and a height of 11. Wow, mine is definitely not drawn to scale. So we can use Google again for this to find the volume of this cone. So to find the volume of the old cone, I went to Google and I just typed in volume of a cone. So here I need to put in the radius and the height. The radius was 3.75 and the height was 11. So here we have that the volume is 161.99. So if that's the old cone, the new one needs to be 25% more. So in order to find out what that is, I'm going to multiply it by 1.25 because that's 125%. And that's 202.49-ish. So now that we have the volume of the new cone and we have part of the dimensions, we just need to find the height. So we know that the new cone still has the same radius of 3.75. The height is what's the mystery. So we just need to work backwards to find the height. And we've done some of those problems before, and those were always a pain. So now I'm going to show you how to use Google to get those. So here on Google, like if you type in volume of a cone, it goes right to this. But if I don't want to solve for volume, I can solve for other things. So you click where it says solve for volume and you change what it is that you're looking for. So I'm going to change it to, I want the height. And it still has our old data in here. So I'm going to remove the volume and put in that new one, the 202.49. So with the new volume, same radius, Google's telling me, well, working backwards, it's just a simple formula. The height has to be 13.75. Here on number 2, it says, a frozen yogurt cone is 12 centimeters in height and has a diameter of 6 centimeters. A scoop of frozen yogurt is placed on the wide end of the cone, like where ice cream goes. The scoop is a sphere with a diameter of 6 centimeters. If the scoop of frozen yogurt melts into the cone, will the cone overflow? So basically we need to find out what has the bigger volume. Is it the cone or is it the sphere of ice cream? So let's just sketch out what it is we're working with. So for our cone, now it says we have a diameter of 6 centimeters, which means we have a radius of 3, and then we had a height of 12. And then for our actual ice cream, frozen yogurt, that's going to be a sphere, also with a diameter of 6, which means it has a radius of 3. So now we're going to go to Google to find out the volume of both of these. So for our cone, we had a radius of 3 and a height of 12, and we're getting that the volume is 113.1. Then for the frozen yogurt, we'll need to switch it to sphere and put in that the radius is 3 and 113.1 again. So considering that they're the exact same volume, I mean, it's very close and I wouldn't want to do this, but if this entire frozen yogurt did melt, it would exactly fit inside the cone. So it would not overflow. It's not the situation I want to be in considering how exact that is, but it would not overflow if you were very, very careful.